Hello students. In this video lecture, we will discuss about the mole concept. What is mole and what is the relation of the mole to the mass of the atoms and the number of atoms. So we'll discuss about the mole concept and its relation to the number of atoms and atomic mass and molecular masses. First of all, student, let's understand what is mole. Now mole is the unit. Mole is the unit to measure the quantity of a substance like dozen. Student, shopkeeper use a unit called dozen to count the number of units. Say suppose when I say 1 dozen of something, so we understand it's a collection of 12 similar objects. Just like that, the chemist use a unit called a mole to count the number of small particles. Now when I say particles, it means atoms, molecules, ions, electrons, protons or neutrons and many other things. So to count the number of particles in a sample, the chemist used the convenient unit called a mole. So like 1 dozen is a collection of 12 similar objects, just like that, 1 mole of a substance for a unit is the collection of this many particles. It's a 6.022 into 10 raised to 23 particles. So 1 mole is the collection of 6.022 into 10 raised to 23 particles. Now student, when I say particles, it means maybe atoms, it may be molecules, ions, electron, protons and neutrons. So what is ions, electron, protons and neutrons, we will discuss in due course of a time. So mole is a unit to count the number of particles. To count the number of particles, it's a collection of 6.022 into 10 raised to 23 particles. Student, this particle, that's a 6.022 into 10 raised to 23 particles, has a special name called Avogadro number. Avogadro number. Avogadro number is denoted by the symbol N naught. N, and we have a subscript here, that's 0. This is called N naught. Let's understand unit. What is this unit? When I say 1 mole of a sodium atoms, students, suppose you have been given a sample of a sodium. Now that sample is 1 mole. So when I say 1 mole of a sodium atoms, it means that sample of a sodium atoms contains this many particles, that Avogadro number of particles of a sodium atom. It's a 6.022 into 10 to 23 particles. And student, pay attention. This 1 mole of a sodium atom, which equals this many particles, that's Avogadro number of a particle, 6.02 to 10 to 23 particles of a sodium atoms, also equals to 23 gram. 23 gram. Now that's the relation between mole, particle and the mass. Now what is this 23 here? Student, this 23 is the atomic mass of a sodium. Atomic mass of a sodium. One table will be provided to you. So you go through that table, you'll come to know what is this 23. So you have to memorize it. So 1 mole of a sodium atom equals this many particles. Now that's the relation between the mole and particle. And 1 mole of a sodium atom also equals to 23 gram. Now that's the relation between mole and mass. So this 2 is the relation between the mole and particles, and this is the relation between mole and mass of a substance. Again student, when I say suppose 1 mole of a sodium atom, it means we must understand it's a collection of 6.022 into 10 to 23 atoms of a sodium, and it also means it's 23 gram sodium. Similarly, suppose if I take 1 mole of an oxygen molecule, when I take 1 mole of oxygen molecule, so that sample contains this many molecules of oxygen, 6.022 into 10 to 23 molecule of oxygen. Now which also equals to how much gram? It's a 32 gram. Now again this 32 is the molecular mass of oxygen. Student, oxygen atomic mass is 16. Now 16 times 2 is equal to 32. That's why we got this 32. Now this 2 means it's an atomicity of oxygen. Oxygen molecule is O2. So from this 2 only we have written 2 here, and 16 is the mass of oxygen. So 16 times 2 is 32. That's how we got this value 32 gram per mole. Now again suppose student, we have been given 1 mole of a water. If I say 1 mole of a water molecules, it means that sample contains this many particles, 6.022 into 10 to 23 molecule of water. Now this also equals to molecular mass of water, that's 18 gram per mole. Now, student, you know how this 18, we got this 18. So water formula is H2O. So we have two atoms of hydrogen. So 2 times 1, atomic mass of hydrogen is 1, plus oxygen is 1. 1 into 16, atomic mass of oxygen is 16. So 16 plus 2 gives us 18. That's how we got this value, 18. So 1 mole molecule, 1 mole water molecule means it's a collection of 6.022 into 10 to 23 molecules of water, which also equals to 18 gram. Now, student, suppose to you 18 gram of water is given. So you must understand it's a collection of a 6.022 into 10 to 23 molecules. So when I say suppose 1 mole of water is given to us, it means 18 gram. If I say suppose conversely, if I say 18 gram of water is given to you, it means 1 mole of water molecule is given to you. So that's the relation between mole and atoms and relation between mole and mass. I hope you understood, student. So what is the relation between mole and number of atoms, and mole and the mass of atoms or molecules? Now, student, mass of 1 mole of a substance is called molar mass. Now see, suppose here 23 gram per mole. It's a molar mass of a sodium. When I say 23 gram, it means it's a molar mass. It's a mass of 1 mole of a sodium atoms. Molar mass of oxygen molecule is 32 gram. It means 1 mole oxygen molecule weighs 32 gram. Similarly, when I say 18 gram, molar mass of water is 18 gram, it means it's a mass of 6.022 into 10 raised to 23 molecule of water. So that's what the molar mass is. Unit of a molar mass is gram per mole. How do you measure the molar mass? Molar mass is measured in unit called gram per mole. Now let's understand the difference between the molecular mass and molar mass, student. Molecular mass and molar mass. In the previous lecture, we discussed about the molecular mass and the way to calculate the molecular masses. So now there is a fine difference between the two, molecular mass and molar mass. See, first difference is what? Mass, molecular mass, mass of one molecule of a substance. Mass of one molecule of a substance. Mass of one molecule of a substance is the molecular mass. Molar mass, mass of 1 mole means 6.022 into 10 to 23 molecules of a substance. Student, you can compare this molecular mass and molar mass as, let's take suppose 1 dozen pencil. That means you have a collection of 12 pencils. If I say mass of 12 pencils, that mass of 12 pencils is the mass of 1 dozen pencils. So that 1 dozen pencils mass can be compared with the molar mass. Now suppose from that 12 pencils, collection of 12 pencils, if I take 1 pencils out and if I measure the mass of that 1 pencils, I can compare the mass of 1 pencils with the molecular mass. So that's how you can understand. So mass of 1 molecule of a substance is a molecular mass, and mass of 1 mole means 6.022 into 10 to 23 molecules of a substance is the molar mass. How do you measure the molecular mass? Molecular mass is measured in unit AMU or unified mass, which we have already discussed in the previous lecture. And molar mass is measured in a unit gram. Let's understand. Give me one example. Molecular mass of water is 18 unit. We shouldn't write 18 gram. Molecular mass means it's a mass of 1 atom or 1 molecule. So molecular mass of water is 18 unit. But if I say suppose molar mass of water is 18 gram. Now student, pay attention to these numbers. Both the numbers are same, 18, 18. The only difference is the unit. If you write suppose 18 unit, you mean it's a 1 molecule's mass. But if you write the same 18 gram, it means it's the mass of 1 mole molecules. Similarly, in case of a suppose sodium, let's take sodium. If I write suppose 23 unit and 23 gram, now what's the difference? When I write 23 unit, it means it's a mass of 1 atom of a sodium. And when I write 23 gram, it means I have a collection of a 6.022 into 10 to 23 atoms of a sodium, which weighs 23 gram. I hope you understood, student, what is the difference between molecular mass and molar mass. Let's move on, student. Here is a relation, mathematical relation between the number of moles and mass, and this is the relation between number of moles and number of particles. And here is the relation between the two, that's mass and the number of particles. What is this n here? Small m, capital M, n, capital N naught. N stands for the number of moles. Small m is the given mass or the known mass which will be provided to, which will be given to you. M is the molar mass that we can calculate using the molecular formula, and the molecular mass, the way we calculated the molecular mass, the same way you can calculate the molar mass. N is the number of particles. Now student, when I say number of particles, it means it may be atoms, it may be molecules, it may be ions, electrons, protons, neutrons, etc. And n naught is the Avogadro number. Now it's a constant number. Even if it is not given in a question, it's understood the value is 6.022 into 10 raised to 23 particles. So it's Avogadro number. So using these relations and this table, student, this is the table that you have to memorize. So elements, these are the name of the elements. It's hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, oxygen, chlorine, argon, potassium, and calcium, and the atomic mass given. So this atomic mass you have to memorize. So using this atomic mass, we'll be solving some of the numerical problems based on the relation between the mole concept, moles, and number of particles and mass. So with that, we end today's discussion, student. Thank you.